This is number 55 on page 112. And so 55, page 112. If you read it, there's a car that is sitting on a hill with an initial velocity 0. It's left out of park with no brakes. So it takes off 4 meters per second squared on this cliff. Is 24 degrees above. Well, it says it below the horizontal, which would be measured from here, but then these are alternate here angles. So it's 24 degrees measured from here also. And it's going to go 50 meters before it reaches the edge right here, and then it's going to fall off like that into the water. All right, so this is a projectile motion problem, but the first part I've got to find the velocity with which it leaves the cliff. That's what I got to do. So to do that, I'm going to use an old equation, which is also an equation we'll use this this test, and that's v final squared equals v initial squared plus 2a delta x. And I just have to plug in here my numbers. V equals the square root. I take square root, right? That's 0. V initial 0, so I don't have to put it. So it's going to be 2 times 4 meters per second squared, and then times the distance, 50 meters. So when you do that, you get V equals a square root of 400 meters squared per second squared, which is 20 meters per second, right? So in other words, this car leaves the cliff at 20 meters per second, 24 degrees. Now here is a big problem people have on the test. They'll use this 20 right here, and they'll put it in this XY table. Remember, we always make an XY table for projectile motion, and we get the 3 variables here from this equation here, and we get the 4 variables on the right hand side from this one here. So we cannot put 20 for VIX, and we cannot put 20 for VIY because it is a 2-dimensional velocity, which means it has an x and it has a y. You'll notice the y is pointing down, it's negative, and so I just have to say, I have to put my calculator, 20 times sine of 24 degrees would be actually negative 24, and that's going to give you negative 8.13. So in the table we'll put it as negative 8.13 meters per second. All right? And then the x, of course, is the cosine. 20 times cosine of 24 degrees is going to give me 18.3 meters per second. So I'll put that as 18.3 meters per second. All right. It tells us that this cliff is 30 meters above the ocean. So what that means is I'm going to make this a delta y we know is negative 30 meters. All right. So if you'll notice here, I have, and if you read the problem, they say B, find the time. We're going to say A, find the time. We're going to find the time first. But you'll notice I have 3 givens and 1 unknown, so I can find the time. I have to use the quadratic equation. So it'd be negative 30 equals 8.13t minus 4.905t squared, right? 4.905 comes from 1/2 times negative 9.81. I'll put my 8.13 there. So to solve this as a quadratic equation, it's going to be 0 equals the positive 30 plus 8.13t minus 4.905t squared. All right, you have a calculator program called the Quadrat. You might have the one from the math department called the Quad. If you'll just put in, you get into that, and for your A, you're going to put negative 4.905. That's always A for us for this chapter for sure. B, you're going to put in 8.13, and C, you're going to put in negative. Sorry, look at that. I forgot to put my negative there. This should be a negative, right? When we look up here, it's negative. And it's real important that you include your negatives in there. So, 8.13. So you're going to include the negative with the B, and you're going to include the negative with the A. And then C is going to be positive 30, right? So you put that in your calculator, and you're going to get time equal to 1.78 when you do that in seconds. Well, the time is the same for the delta x, and so the A part, which is going to be the B part for us, is plugging into this equation, delta x equals 18.3 meters per second times 1.78 seconds. And you get 32.6. Alright? 32.6 meters. That's how you do that problem. It's got two parts. The first part, you've got to use this equation to find the velocity here, and then the second part is what we're doing in this chapter. It is just using the two equations, delta y and delta x, in this table to find what they want us to find, which was time and delta x. So I circle my answers. That's one answer. There's my other answer. All right, and that's it.